Good morning, dear students. Today we are going to start with the new topic of chapter alcohols and phenols, that is, chemical properties of phenol. Acidity of phenols. The reaction of phenol with metals like sodium and aluminium and sodium hydroxide indicates its acidic nature, because we have seen in that reactions there is liberation of hydrogen, which shows its acidic nature. The hydroxyl group in the phenol is directly attached to the sp2 hybridized carbon of benzene ring. We know this very well, which act as electron withdrawing group. And all the electron withdrawing group increases the acidic nature of phenol. Due to this electron withdrawing groups, the charge distribution in phenol is increases as depicted in it the resonance structure. Let's see the resonance structure. Now you can see in the resonating structure of phenol. When OH is there, the lone pair of electron of oxygen gets delocalized, and because of that there is a formation of double bond with a positive charge oxygen. So you can see here negative charge. Now this negative charge gets delocalized to all the position, and you can see all these resonating structures. So when the bond breaking of OH will be there after the formation of all the resonating structure, obviously this bond will break and H will remove as H positive. So what will happen? This proton get easily depart because the leftover phenoxide ion gets stabilized by the resonating structure. You can draw the resonating structure of this phenoxide ion also. So this shows that phenol is acidic in nature. Now when you will compare the acidic nature of alcohol and when you will compare the acidic nature of phenol. So in alcohols we have already seen that alcohols are less acidic than water, right? But now you will see phenols are more acidic than alcohols. How? Let's see. When we talk about the acidic nature, in both the cases we know that there is a breaking of OH bond. In case of alcohol also, in case of phenol also. So when alcohol form alkoxide and phenol form phenoxide. So here formation of alkoxide ion and here formation of phenoxide ion. This phenoxide ion gets stabilized by resonance. As I told you in the previous slide, resonating structures are possible for the phenoxide ion. So due to the resonance it gets stabilized, and due to more stability the acidic nature of phenol is more as compared to the alcohol, and we can prove it by the reaction of aqueous sodium hydroxide, which indicates phenols are stronger acid than alcohol and water. I hope when question will be asked about the acidic nature of alcohol and phenol, it is clear to all of you. In substituted phenol, the presence of electron withdrawing group like nitro increases the acidic strength of phenol. For example, if phenol is there or any electron withdrawing group like NO2, if NO2 is present on any of the orthometa para positions, then it increases the acidic nature. So, if you will compare any phenol compound and any substituted phenol substituted with NO2, then this substituted product is more acidic as compared to the phenol. The effect is more pronounced when such group is present at ortho and para position, because it is due to the effective delocalization of the negative charge in the phenoxide ion. So this group, electron withdrawing group, it increases the delocalization of negative charge. But on the other hand, electron releasing group. Now what are the electron releasing group? Like alkyl group. Any of the alkyl group is present over the phenol. So what will happen? For example, if phenol with any of the alkyl group, for example, if I say cresol, this is orthocresol. If CH3 is meta position, metacresol. If it is at para position, paracresol. So if any alkyl group is there, it do not favors the formation of phenoxide ion, because it is electron donating group. If it will donate electron, it will affect the release of hydrogen. It will not let the hydrogen to go easily, which decreases the acid strength. As I have given you the example of cresol, cresols are less acidic than phenols. Let's see the reaction of phenols. First is electrophilic substitution reaction. Electrophilic substitution reaction in phenol directs the incoming group of ortho and para position. Means, as you know very well, if benzene ring is there and OH. So when you will see the resonating structure, negative charge is coming at ortho and para positions, right? So the incoming group, whatever the group is coming, will come at ortho and para position. It means it directs the incoming group at ortho and para position. Let's see how the reaction will. Phenol react with dilute HNO3 and give rise ortho and para products. Here you can see mixture of ortho and para products are obtained, but they can be separated by steam distillation, because ortho is steam volatile while para is not. As you can see the reason, in orthonitrophenol, intramolecular hydrogen bonding is present, but in paranitrophenol, intermolecular hydrogen bonding is present, which give rise association of compound. So due to association, boiling point increases. So you can give the reason for the same. Paranitrophenol has more boiling point compared to ortho due to intermolecular hydrogen bonding. With concentrated nitric acid, phenol is converted to 2,4,6 trinitrophenol. Means attack at all the three positions, both ortho and para, takes place together, which give rise 2,4,6 trinitrophenol, and this is known as picric acid. So the name picric acid is given. Reaction can be asked for the same picric acid. How you can synthesize the picric acid? So the structure for the picric acid is we will see in the next page. Now the yield of the reaction is poor. Picric acid is prepared by treating phenol with concentrated sulfuric acid, which converts into phenol 2,4 disulfonic acid and then concentrated nitric acid. So in acidic medium, reaction will takes place. This reaction will take place in the acidic medium. So here you can see with concentrated HNO3, the attack will be at ortho and para position. So the product form is 2,4,6 trinitrophenol, also known as picric acid. So next is halogenation reaction. On treating phenol with bromine, different reaction products are obtained under different experimental condition. Please keep this thing in your mind. Ortho-para product formed at different condition and 2,4,6 substituted product form at different reaction condition. When the reaction is carried out in a solvent of low polarity like chloroform or carbon disulfide, then monobromophenol is obtained. The usual halogenation of benzene takes place in presence of Lewis acid like AlCl3, FeBr3, etc. In case of phenol, polarization of bromine molecule take place in absence of Lewis acid. It means in normal halogenation this is required, but in case of phenol it is not mandatory because of highly activating OH group. Due to the presence of highly activating OH group, this is not required. You can see in the reaction when phenol react with bromine in presence of carbon disulfide. So ortho and para substituted products are formed. So here you can see the reaction condition is bromine with carbon disulfide CS2 at 273 Kelvin. Next you can see the reaction with bromine. In this 2,4,6 tribromophenol is formed. Here bromine react and at ortho and para position are occupied by bromine. So product is 2,4,6 tribromophenol. Next is Kolbe's reaction. This is a name reaction and very important reaction. In this reaction, electrophilic substitution reaction takes place with carbon dioxide, which is a weak electrophile. You can see the reaction here. You can see the phenol when react with NaOH. So there is removal of water molecule. Water molecule will be removed and formation of sodium phenoxide takes place. This reagent is known as, this intermediate is known as sodium phenoxide. This is sodium phenoxide. So sodium phenoxide is obtained, which react with carbon dioxide in acidic medium. First carbon dioxide will react and then reaction with HCl. So when carbon dioxide will react, then with the acid, it will give rise salicylic acid, also known as IUPAC name, 2-hydroxy benzoic acid. So in coal-based reaction, we can form 2-hydroxybenzoic acid or salicylic acid from phenol. Next and very important reaction is Riemer-Tiemann reaction. On treating phenol with chloroform or with carbon dioxide, you can use chloroform, or instead of chloroform you can use CCl4, carbon tetrachloride. CCl4 also can be used. CCl4. So what will happen? CHO group is introduced at ortho position of the benzene ring. Here you can see the reaction. In this reaction you can see when phenol react with CHCl3 in basic medium NaOH. So first of all, water will be removed and sodium phenoxide will be obtained. When we talk about CHCl3, so one hydrogen from here and one chlorine from CHCl3 will remove as HCl, and the remaining CHCl2 will be attached here. So what will happen when again it react with base? You can see the reaction ONA and here CHCl2, right? So when it react with NaOH, so two molecules of NaOH will be there. So one molecule will remove one NaCl and another one more molecule will remove one more NaCl, and both the OH will form the bond with the carbon. So what will happen? It will give rise a structure like this. Phenol, ONA, carbon bonded with hydrogen here. Now Cl gets substituted by OH. Now this is a compound on which carbon having two OH. So there is a removal of one water molecule because it is unstable. So as the water molecule will be removed, then CHO, aldehydic group, will form. In this way, salicylaldehyde will be obtained. But instead of CHCl3, instead of chloroform, if you will use CCl4, then what will happen? Here, instead of CHO, COOH group will be obtained. So, with chloroform, salicylaldehyde will be obtained. With carbon tetrachloride, salicylic acid will be obtained. So, you can synthesize salicylaldehyde or salicylic acid with the help of Riemer-Tiemann reaction. Next is reaction of phenol with zinc dust. This is a reduction reaction. When phenol gets reduced with zinc, then what will happen? Zinc and oxygen, it will remove as ZNO and benzene will be obtained. So you can convert phenol into benzene by heating it with the zinc dust. Next is the oxidation reaction. Oxidation of phenol with chromic acid produces conjugated diketone known as benzoquinone. It means oxidation of phenol will take place at both the position, here also and here also. So, in presence of oxidizing agent, strong oxidizing agent, the reaction will be formed and the product form is known as the benzoquinone. Now here your phenol chemical properties are over. Now we have to see some commercial important alcohols For the board perspective, this is not very important topic, but then also we have to go through these topics. First is the methanol. Methanol is also known as the wood spirit and is produced by the destructive distillation of the wood, and this is the reason why it is known as the wood spirit. Methanol is generally produced by the catalytic hydrogenation of carbon monoxide at high pressure and temperature in presence of zinc and chromium oxide. You can see the reaction when CO, carbon monoxide, react with H2 and it form the methanol. So this is the method of preparation of methanol. Next is few properties of methanol. When methanol is this methanol is colorless liquid and its boiling point is 337 Kelvin. It is highly poisonous and sometimes it is mixed with the ethanol, so that the consumption of ethanol in the factories and companies should not be there. It can be banned by the addition of the methanol. But sometimes when it is mixed with the ethanol and if it is consumed, then it may give rise to death, blindness and many other diseases. Ingestion of small quantities causes blindness and even the death. It is a solvent used in paints, varnishes and chiefly for making the formaldehyde. Formaldehyde is a solvent or the reagent which is used for the preservation of biological specimen. Next is ethanol. This is the reagent or the solvent you know very well. It is obtained by the fermentation process. Sugar in molasses, sugarcane or fruits like grapes, potatoes converted into glucose and fructose in presence of the enzyme known as invertase. So invertase will convert these into the glucose. This glucose and fructose undergo fermentation in presence of the enzyme zymase, which is present in the yeast, and give rise the compound known as ethanol. You can see the reaction. This is the sugar. When this sugar react with invertase, it give rise glucose and fructose. This glucose and fructose in presence of zymase give rise a compound known as ethanol, and carbon dioxide will be released as a byproduct. This is a colorless liquid with boiling point 351 Kelvin. It is used as a solvent in paint industries in preparation of many carbon compounds. You know it very well. It is a good solvent. It is used in the spirit lamps also, and many more uses are there. You will see in the coming chemistry. Commercial alcohol is made unfit for drinking by mixing it with the copper sulfate, pyridine, and is known as the denaturation of alcohol. This term alcohol is previously for the ethanol especially. But you know alcohol is the compounds having the OH. So this denaturation of alcohol means the mixing of impurities in the ethanol. And large quantity of ethanol is obtained by the hydration of ethene. You have seen the reaction in the method of preparation. Hydration of ethene means ethene CH2 double bond CH2 when react with HOH. This reaction will take place. So H will go on this carbon, OH will go on this carbon, and there is a formation of alcohol. Now, when we will have the next video, our next topic will be ether. Here we have completed alcohols and phenols, method of preparation, physical and chemical property, uses, and some commercially important alcohols. So in this chapter, one more topic is there that we'll see in the next video, ethers. Thank you and God bless you.